Welcome to the Allplan QuickStart Lesson 7. In this lesson, we will learn how to generate 3D reinforcement in concrete members and specifically focus on area reinforcement. First, we'll start with a brief overview. Allplan makes it easy to model 3D reinforcement in your concrete members, including walls, slabs, columns, beams, and foundations. You can also reinforce a variety of shapes or structures ranging from underground tanks, water towers, tunnels, and more. Anything you can model can be reinforced in Allplan. Modeling of 3D reinforcement can be a powerful and competitive edge to your business. It helps to generate more accurate drawings with better visualization and representation to be shared downstream. This results in better coordination and less field issues. With very little additional upfront time, you can market these benefits to win more work and increase revenue with budget-saving modeling. In Allplan, the reinforcing of elements follows the basic philosophy of a 2D to 3D workflow. This helps to ease the learning curve and a successful implementation of the software. This means you'll work off 2D views and sections, and the 3D rebar is generated automatically. Allplan combines a CAD background with the benefits of BIM. This means the reinforcement has attributes that can be associative with labels and reports, making change management easy. There are built-in rebar shapes available for quick modeling, or you have the flexibility to generate free-form reinforcing of any shape and location. Allplan has a library of built-in parametric members with automated reinforcing. These Python parts are outside the scope of this training session. Please contact us if you'd like more information on using and working with Python parts. We will look at two main ways of modeling rebar in this and the next lesson. These are the bar shape command and the area reinforcement command. In many cases, either option will work, and it comes down to personal preference. However, in some situations, one may be a better option than the other. The bar shape command gives you more flexibility and control over placing reinforcing, and it's best for columns, beams, and complex or unique shapes. A strength in Allplan is that you can model any shape or structure using 3D freeform modeling tools. For example, we can quickly generate a stepped footing using 3D surfaces and extruding the faces with simple push-pull commands. We then need to rotate the shape and create a section to model the reinforcing. We will look at this in more detail in the next lesson, but for now you can see how quick and easy it is to click within the structure and generate reinforcing of any shape and layout. The area reinforcement command is great for reinforcing walls, footings, and slabs. This command allows you to define a polygon and quickly generate uniform reinforcement within that area. Let's start by taking a closer look at using the area reinforcement command to reinforce the foundation elements. Open the building structure by double-clicking in an empty space of the viewport. Turn on the foundation story and set drawing file 102, foundation reinforcing, to active. Set drawing files 101 and 103 to edit mode. Now we're ready to start modeling the reinforcement. In Allplan, we use the sections and views to model reinforcement, and we will see this generates the 3D rebar automatically. Zoom into the plan view and sections that have been created. We'll start by reinforcing the spread footing under a column to show how quick and easy the area reinforcement command can be. The center footing is represented by section 44. Again, we can confirm this by hovering over the footing and seeing it highlighted in all sections. In the reinforcement ribbon, click on the Area Reinforcement command. Select the Span Reinforcement option. Notice the command bar at the bottom of the screen. Here we can define a cover from the edge of the polygon for where the reinforcement will be placed. Indicate -1.5 inches so the reinforcement starts 1.5 inches from the edge of the placement area. Just to the right, make sure the area detection command is depressed. This allows us to simply click on an existing closed area to define where the reinforcement will be placed. Alternatively, you could click on the corners to define the area manually. In this dialog box, we need to identify where the reinforcement will be placed. Use the 2D section to set the elevation height of the rebar. the thickness of the footing, and the concrete cover from the bottom of the element. Click OK to confirm, and next set up the details of the reinforcement. We can define the rebar size and spacing here. For now, click OK to confirm. Notice in both the section and plan view, we can now see the reinforcement being generated. At this point, we are prompted to add a label in plan view for this reinforcement. In the Properties palette, you have many options for how the label will look. You can then click in the graphics to apply, or press Escape on your keyboard to skip this step. Labels can be added at any time, and we can come back to this later. We are still in the span reinforcement command, and now we have the option to match the reinforcing. This will retain all the information we previously entered for these bars, including the placement area and rebar properties. Notice the command automatically increases the covers so these bars sit on top of the previous and rotates the bars to the opposite orthogonal direction. We can make changes if needed or simply confirm to draw the bars. Simple CAD commands can be used to work with reinforcement. Now to generate the top bars in the footing, we can easily use the mirror command and copy the bars to the top. We can expand this concept to reinforce the strip footings under the foundation walls. Activate the area reinforcement command and click on span reinforcement. Again, we can define a cover from the placement polygon where the rebar will be placed. This time, we're going to manually define the area by snapping to the corners that form the strip footing under the east wall. Press Escape when done to complete the polygon. The rest of the steps are the same as we've seen for the footing. Once you've learned the basic commands, it's easy to apply these concepts to other areas of the model. Once done, use the match command to now generate the longitudinal bars in the strip footing. Here we can define more information like the maximum length of bars. The program will then automatically splice the bars and use the input overlap values to correctly lay out the reinforcing. Click OK once done and either add labels to the plan drawings or press Escape to exit. You can now review the reinforcing in the plan, section, or 3D views. We can use the area reinforcement for the curb on the strip footing. For this element, we need to use an elevation view of the wall. Make sure to remove all hidden lines so that the elevation view is only showing the outline of the wall itself. This allows us to quickly use the area detection command as opposed to snapping to the corners of the wall. The area span command does give you some flexibility in defining different parts of the polygon once it's been established. Here we can change the offset for each individual side. Click on the offset command, look to the command bar for the next steps, click on the side of the polygon where you want to input a different offset. For the longitudinal bars in the wall, we may want to extend the bars into the strip footing with a hook at the end. We can define the offset here as +8 inches. You can see the placing polygon is now showing this newer depth. To add reinforcing in the wall, we need to rotate the way that we're working. Instead of using this section to define the elevation and thickness, we now use the plan view to define these locations. Set the cover as 4 inches to place the bars as a single layer near the middle of the wall. Again, we can set the different properties of the bars and spacings. Here we can define different end conditions for the bars at specific locations along the polygon. Select this command, and in the dialog box, choose what the end condition should be. Then click on the edge of the polygon where you want to apply this edge condition. We can easily add a hook to the bottom of these extended bars into the strip footing. Select OK and Escape to confirm and complete the bar generation. Once done, you can see the generated reinforcing, and you can see it here in the elevation view with the bars extending into the footing. You can confirm it in the 3D view, and we can also see it in the section view. We can now match these bars and generate the transverse reinforcement in the wall. Using the same steps as before, set the polygon offset at the bottom back to 1.5 inches. Confirm all other properties as shown and complete the reinforcing bars. Using the same steps as before, remember to change the end of the bar to a straight bar instead of a hook. Notice in all views that we've completed the foundation wall reinforcing very quickly, showing accurately in 3D where the bars will be placed. In the next lesson, we will look into the bar shape command and how it can be used to reinforce different elements.